Yeah, thank you. I'm going to talk about power line communication security on smart meters today, and I will explain a red team approach on smart meter security and power line communication security as well. So, about me, I'm an IoT penetration tester and team leader at business cybersecurity company located Turkey, and I am also one of the organizer and instructor the Turkey ICS IoT cybersecurity bootcamp, and I like research new things. And disclaimer: these materials are for educational and research purposes only. So, in our agenda, first I will start the basics of smart grids and smart meter system and data communication in smart grids, and I will explain the theoretically power line communication and security, and we will go a red team approach on smart meter. So, what is smart grids? And smart grids is an electricity network based on digital technology that used to supply electricity to consumer via two-way communication. Actually, the key feature is two-way communication in a smart grid system. And smart grid allows for monitoring and analyzes control and communication within the supply chain to help improve the efficiency, reduce energy consumption and cost, and maximize the transparency and reliability of the energy supply. And the smart grids was introduced with the aim of overcoming the weaknesses of conventional grids. And many governments, as you know, institutions around the world have been encouraging the use of smart grids to control and deal with global warming or emergency resilience and energy independence scenarios. So, actually, smart grid is an extended form of analog technology. It also includes for controlling to use appliances and by employing two-way communication. And smart grid devices transmit information in a such way that enables ordinary users or operators and automated devices to quickly respond to changes in smart grid condition system. So the entire smart grid is automated for tracking the electricity consumption or location. And grid architecture is also combined with energy management software for estimating the energy consumption and it associated cost for specific enterprise. And energy generation looks like a stock market, as you know. Generally, electricity prices increase along with demand. By providing consumer with information about current consumption and energy prices, smart grid energy management services help to maximize the consumption during high cost or peak demand times. And if you look up the smart grid's key features, there is three main features. There are three main features. The first one is load handling mechanism of smart grids, and the total of power grids is not stable and it varies over time. So in case of heavy load, a smart grid system can advise customer to temporarily minimize energy consumption. Or the second one is demand and response support. Provide users with an automated way to reduce their electricity bills by guiding them to use low private electronic devices when rates are lower. And the third one is decentralization of power generation. Actually, the main key features is decentralization of power generation with smart grid, and a distributed or decentralized grid system allows the individual user to generate on-site power by employing any appropriate method, such as wind turbine or solar panel. And with decentralization of smart grids, we will use renewable energy in the future more often than today. And there are differences between smart grids and conventional grids. To sum up, and the first, distributed smart grids have distributed smart power plants, but conventional grids have large power plants. And so we'll say smart grids are decentralized and conventional grids are centralized because of using large power plants. This means in conventional grids is one or two power plants would be shut down. All grids could lose its power. Actually, 5 years ago in 2015, in Turkey, we faced a scenarios like that. One of the main power plant was shut down and we faced a blackout situation in a day. The third one is related to second one, actually. Smart grids have a scale regional transmission, but because conventional grid architecture, there are large power lines and pipelines. And smart grids provide two-way communication between supplier and consumer. But conventional grid has a one-way communication. Actually, this is not a communication. This is just transmission, the electricity power to consumer, to supplier to consumer. And in smart grid, consumer are active in the system because system can track consumption data and consumer manufacture the electricity, but conventional grid, we just pay our bills. We are not participating in this system. And we talk about there is a connection between supplier and consumer, and the key element of this connection is smart meter. And smart meter records consumption and communicates the information to the electricity supplier for monitoring and billing. And smart meters typically record energy hourly or more often. It depends on your configuration, actually, and report at least a day or twice a day to central system. And smart meter system called Advanced Metering Infrastructure, AMI. And advanced metering infrastructure differs from automatic meter reading in that enables two-way communication between the meter and the supplier. And communication from the meter to the network may be wireless or via fixed wire connection, such as PLC, but this PLC is not programmable logic controller. This is a power line communication, actually, and maybe wireless communication, such as cellular communication like GSM or APN network or Wi-Fi, LoRa, Zigbee communication. And with smart meter, actually, smart meter have more advanced feature than conventional meters, such as you can detect the electricity theft with smart meter because you can monitor the full system and analyzes and consumption data. And smart meter provides billing and shutdown for electricity or consumer remotely. So there is no need an officer to read or shut down electricity on the field. And we talk about PLC smart meter, and PLC smart meter has its own internal battery, because if there are no electricity online, meter cannot work. But what does it mean, meter cannot work? Because there is no electricity, so I don't need to measure data. Actually, this is not true, because electricity theft, actually electricity thieves are thinking like a hacker mindset. General electricity thief can disassemble the meter and can switch the phase cable for fraud data. But without power, meter can store whether it disassembled or not. And when electricity power comes line, it transmits the data to center. And smart meter use International Electrotechnical Commission ISC 62056 protocol, or as known, DLMS COSAM protocol. I'm going to talk a little bit about these protocol details in the next few slides. And power line communication. Actually, power line communication carries data over existing power line cable lines or alternative current cable lines. Carries data on a conductor such as copper, and it also simultaneously for AC electric power transmission or electric power distribution to consumers. And PLC systems are based on the idea of networking without the need for new cables. So actually it's a cost-effective solution. And power line communication is extensively used in smart meters or advanced metering infrastructure. And PLC provide communication between transformer and smart meters. Actually, plugs can become an input point for attackers, but it depends on the configuration and infrastructure and smart meters. Actually, this is not possible always. And around the world, grids use different voltages, such as in Europe, we're using 220 volts or 50 hertz. In USA, it's different than Europe. And with PLC, data is modulated on a carrier signal. On the right side of the screen, you can see three graphics. And the first one is a digital signal that it maybe read out data from smart meter. And the second one is a carrier signal. And the carrier signal actually the electricity power on line of 50 hertz to 220 volt carrier signal. And the third one is modulated signal. And actually, this FS key modulation, frequency shift key modulation on the third graphic. So let's look up the smart PLC communication and smart meters infrastructure. On the left side, of the screen, you can see the houses or street light, and each of them have one meter, and this meter communicates with data concentrator via power line communication. And you can think this data concentrator as a router, as a regional router actually. And this data concentrator is located at regional transformer. And it communicates to center with an APN line or radio frequency line or cellular GSM line. It depends on the configuration. And according to manufacturer, one data concentrator can manage up to 2,000 smart meters, and on the right side, there are backend system or back office system for monitoring and controlling smart meters. And we talk about readout or consumption data. So actually, it's quite simple. Backend system scheduled readout consumption on smart meter according to configuration, and one times or twice a day, and readout process has been triggered by backend. So the request came to data concentrator via APN or radio frequency line. So APN and data concentrator broadcast a frame on power line. And could you send your readout data for smart meter ID1? And smart meter received this data. Actually, all of these smart meter received this frame, but only smart meter ID1 replied. And smart meter ID1, hey, here I am, and this is my readout data, and this data came the data concentrator, and it transferred via APN or radio line to backend system. And actually, the process is so simple, and all of the processes are like that. And we talk about to shut down smart meter remotely, and actually it's quite similar like readout data, and data concentrator gave order for ID3 and shut down your electricity, and these data came to data concentrator, and data concentrator broadcast a frame to power line, and smart meter ID3 shut down the signal and replied to backend system, okay, I shut down the electricity on me. And actually, where is the attack surface of that? Between the smart meter and data concentrator, we can sniff, intercept, and replay the traffic. But there are many challenges in between smart meter and data concentrator, because there is a AES encryption, and you have to deal with the modulation, and general manufacturer are using their patented modulation system, so you cannot demodulate the signal from line so easily, because there is no document about it. Actually, I used for smart meters to demodulate and encrypt the data on power line, because smart meter has a component to do it. And actually, I didn't use any additional hardware for this pen test. And with that, you can send fraud readout data from meter, or send fraud shutdown or fake shutdown frames to other smart meters, because the communication is broadcast communication, like ARP protocol, and I use, in our case, I use the UART communication between MCU and the chip that demodulated signal, or an AES encryption signal. So I use the UART communication between of that, and I manipulate the data on this UART communication. So this is a frame, a shutdown frame from data concentrator to smart meters. Actually, there is a 8-digit smart meter ID, but this smart meter ID are increasing respectively. You don't need to do brute force it. And actually, I captured this frame in hex format, but I converted it to ASCII for reading. And this ID is unique in smart meter and being assigned in manufacturing phase. And there is an OBIS code, and in that 9674 OBIS code for shutdown signal, it's defines at DLMS code and for shutdown signal OBIS code. And this frame is readout frame from meter to data concentrator. And you can see the readout data. All data are 0 because we were using the test environment in a pen test phase. And you can see the readout OBIS code at bottom, and 9670 and 9671 is for the readout at DLMS COSAM protocol. And there is a smart meter ID, and it's 8-digit smart meter ID as well. And as a conclusion, sniffing traffic from power line with external hardware is possible theoretically, but it's not possible practically because there are too much challenges to do it. For example, the demodulation or dealing with AES encryption or working with high voltage and high current could be dangerous because I'm used to work low voltage, as you know, 5 volts or 3 volts. And actually, while I was testing one meter exploded in my hand because of short circuit, but it didn't hurt me. I'm still alive. And sniffing or replaying traffic from smart meter or data concentrator to power line is possible, and because meter can handle the demodulation and encryption, and it's a simple way to do it, to use a smart meter. And if you can control smart meter via debug ports such as JTAG or SWD or maybe UART, probably you can manipulate readout data or shutdown signal. And in my opinion, exposing the debugging port could be dangerous. If you need to expose them, you should put an additional security solution, or you should do some obfuscation for it, or you should use JTAG enabling, or actually you shouldn't expose too much detail in your console. And thank you. That's my presentation is over. Actually, I want to thank to IoT Village volunteers for giving that chance and organizing this awesome event as a virtual. And I will be online at Discord channel and for your question. Thank you.
We think about IoT Village as a movement. These devices are being adopted so rapidly that security is not effectively being baked into the development and deployment of those solutions. That puts consumers at risk, that puts businesses at risk, that puts governments at risk. And what we're trying to do is to galvanize a community around solving that problem.
Every time somebody hears IoT, they immediately think, I don't want this in my house. But as time goes by, that choice of having something in your house or not is not really there.
You can walk in the village, you won't feel like you're asking a dumb question, and you'll still walk away learning something no matter what your skill level is or knowledge.
IoT Village provides an opportunity for people to experience security in a very tangible, very real way.
So what ends up happening is, I can kill Lisa right now. She's being smothered. She's flatlining, patient monitor's going nuts, she's dead. What's going on at the nurse's station? She's fine. What I'm doing right now is we are replaying recorded data of a healthy patient. So this patient monitor is something you'd see in every hospital room in America probably. The IoT Village seeks to raise awareness of IoT security. We want consumers to be able to make informed decisions, and we want manufacturers to improve their security.
So we put a lot of work into the security on the Bird 2, and we wanted to put it in front of the DEF CON community and see what people were able to do with it. We've learned stuff about our tech that we didn't previously know, and from my perspective, that's phenomenal because we have a really talented team internally, but when we can be educated by people external to the company, it's a big, big win.
We really want to show that we very much welcome the work that security researchers do, and even though we work in a world, a medical device world, that's not as accessible to the people that work in this space, we really value the input that researchers have. We want to show that we love for them to work with us on medical devices and what they can find in it.
Security is a mission-critical part of being a pioneer. And by participating in this, they're able to address some of the challenges that are introduced through innovation.
Building a contest to challenge hackers, at the world's biggest hacker conference, if these guys didn't know what they were doing, this room would be empty.
So IoT Village is awesome. Unfortunately, like a lot of hackers work in these small groups, they don't really share a lot of information because they kind of want to monetize or capitalize off of the information that they have. So being here in IoT Village gives us an opportunity to talk to a bunch of other hackers that we wouldn't normally talk to and share information and kind of like come together as one.
I think it is the best thing since sliced bread, personally. This year we're here at DEF CON helping run a hands-on lab, IoT Hacking 101. How do we get people involved with this? Because it might be intimidating, right? Walking up into a big CTF at a big conference. The idea is that we handhold them all the way through from the basics of firmware analysis right through to discovering a bug and popping a device or two.
I just connected over Netcat. There was nothing fancy, no authentication, anything like that. And this number here is your authentication token. It's a serial number on the device. That's what they're using for authentication. So what we're doing is that we're showing people how we find vulnerabilities in embedded devices. Specifically, I've been targeting NAS devices, and I've been showing how we find vulnerabilities, develop an exploit for it, and exploit it from the attacker's perspective.
IoT Village is the face of IoT security worldwide. They're probably the most preeminent brand when it comes to dealing with IoT security. We have expertise, they have expertise, and we feel that it's more than just a sponsorship, it's more of a partnership in which we share stuff with each other. The visibility that you get from all of these conferences is an amazing thing.
It's only going to get more and more relevant, and the devices are only going to get more and more prevalent. And so I think it's just a great interactive, hands-on experience for people to come and get immersed.
We know that these security challenges that are inherent within connected devices, they're not going away on their own. We're able to make these challenges come alive, to become real, to be tangible. And when we do that, we enable people to participate in being part of the solution.